Hello and welcome to the third in a series of interviews that we are running in the build-up to Future Manufacturing Technologies Conference and Expo 2019. My name's Philip Bell. I'm from Go-Konnect, the organisers of the event, and I'm very happy to be joined by Ross Friel. Today, Ross is an associate professor at the University of Halmstad in Sweden, and he will be speaking on the 3D printing live stage at FMTX in Malmö this May. So firstly, good afternoon, Ross, and welcome. It's great to speak to you today.
Yeah, afternoon, Philip. Yeah, thanks very much. Nice to talk to you too.
Good stuff. So we'll dive straight into the questions.
Sure.
Your presentation at FMTX is entitled Printing with Moon Dust. A very interesting title. So can you give us a little bit of background on how this project came about and what the objectives are?
Yeah, sure. So in sort of 2012, I was approached by an engineer, a space engineer called Sean Whitehead. And he was interested. He had this material that he called lunar regular simulant, which for me means moon dust.
Yeah.
And we were interested to see what happens if we hit the dust with a laser, a high-powered infrared laser, what would actually happen. And to our surprise, it actually responded pretty well, and it stuck together, and it gave the inclination that if we could layer up this system, we could actually have a 3D printer with this material. So I then recruited a PhD student called Thanos Gulas, and together we started to really investigate if we could firstly melt this in a controllable way, then get it to layer up. And really the objectives for us were to understand these processes and use them, so that the big overarching thing being that perhaps you could send a 3D printer to the moon and you could actually build something with the material that's already there. So that was low level objectives.
Okay, exciting stuff. Seems like, as I said earlier, a very interesting topic area. So can you really see 3D printers being sent to bases on the moon or Mars?
Yes, absolutely. Yeah. So, I mean, NASA they already have a 3D printer on the International Space Station right now. So, and then for a big challenge for any future space missions is going to be self-sufficiency.
Yeah,
so
of course.
It's very difficult to get a lot of weight off the ground and to the moon. So typically astronauts travel very, very light, and this makes them particularly vulnerable to things going wrong and not being able to make their own repairs or spares, and once they get there, they really need something they really need a material and a way of manufacturing to sustain themselves if we're serious about saying that. So I think being able to get a 3D printer up and onto the moon and then have this abundant supply of moon dust manufacturing material would be really great, and would really allow them to really start to explore. Instead of it being a day trip to the moon, it could be a bit more serious, a bit more long term.
Yeah, cool stuff. And based on the research that you've been undertaking, what would you see are the kind of key applications or products that could be printed using these materials?
Yeah, so what we've been doing in our research, so we've made filters, which is useful, and we've also made sort of spare components, fasteners, things like this, screws. But really for us, what stands out as being particularly useful is blocks. Is actually construction building blocks, and this is sort of large scale, so that you could build a building. And this sounds maybe not as much fun as a filter, but the really interesting thing is that the moon and also Mars, you're not protected like you are on the Earth. They are exceptionally dangerous environments, regardless of the fact you can't breathe. But on top of that, if you ever have if the sun ever, which we get every so often, we get these solar emissions or anything like that, you're actually bombarded by quite nasty levels of radiation. So it's not a nice place to be. And the only real sort of effective method against those is something big, heavy, and dense. And that's what you need. You need a brick wall between you and the radiation. So a really great thing is that if you can repurpose the moon dust and actually make these thicker, stronger structures, you could really make a sustainable and far safer environment on the moon and also on Mars.
Okay. Yeah. Wow. really exciting stuff. It's just put some ideas into my head of the potential for building these bases on Moon and on Mars. So from a Earth perspective, is there kind of transferable knowledge that we can take from this research and apply to applications here as well?
Yeah, so something that's shown up that was really interesting is a lot of these materials, although they are Moon and Martian materials, the Earth has a similar abundance of some of these materials as well. So a great thing that's enforced with space travel is that you have to be really resource efficient. You have to use just what you need and in a most sort of efficient manner you can. And that has great implications for the Earth, particularly for deprived areas or areas where it's difficult to get materials. You could essentially use 3D printing and the indigenous materials around you. So the materials that are already there. So no shipping concrete, no shipping steel. You could actually use the material you find around you with the printer, build constructions, build roads, build houses, build whatever you want. And that would be really interesting, particularly in this challenge we have of reducing our CO2 emissions and everything. Course. So this idea of kind of localized sourcing of materials and localized construction would be something very powerful. We think this is kind of a transferable output from this research work.
Okay, wow. So sounds like there's some great potential going forward, and printing with moon dust will potentially be a big part of the future exploration of our solar system. And there are plenty of Earth-based applications that can help to give us the more resource efficient outcomes that you mentioned as well. So really, really interesting stuff, and I'm very much looking forward to hearing you give the presentation on the 3D printing live stage.
Yeah, thanks very much. I'm really looking forward to it.
Good stuff. Okay, well, just finally, we'd like to thank you for your time today, Ross. It's very much appreciated. And if you are watching this and would like to see Ross speak about this subject in more detail at FMTX, then you can purchase tickets online at www.fmtexpo.com. And we look forward to seeing you there.
Great. Yeah, happy to be there. Thank you.
Good stuff. Thanks, Ross. Cheers.
Yeah, thanks, Philip.